Hello everyone, welcome to my chemistry presentation. I am Dhiraj Agrawal. I am studying PG in chemistry from RLT College of Science, Akola. Here I am going to give presentation on Raman spectroscopy. So in this presentation, I will give you introduction of Raman effect, scattering of light, vibration and rotational Raman spectroscopy, then characteristics and their application of Raman spectroscopy. So let's see the introduction of this topic. Raman spectroscopy was discovered by Sir C.V. Raman in 1928. It is a spectroscopic technique used to observe vibrational, rotational and other low frequency modes in a system. Raman spectroscopy is a commonly used in chemistry to provide a fingerprint by which molecules can be identified. When the radiation passes through the transparent medium, the species present scatter a fraction of the beam in all directions. Raman scattering results from the sum type of the quantities vibration change associated with IR spectra. The difference in wavelength in between the incident and scattered visible radiation correspond to the wavelength in mid IR region. This is a small introduction of Raman spectroscopy. Now, before we proceeding further, we will know what is this scattering effect. We comes across many questions in our everyday life, such as why sky is blue, why does sun appear red at sunrise and sunset, why red color used as a danger, why sky is a white at noon, etc. In this section, we are going to deal with the phenomenon responsible for this thing, that is scattering of light. When a light or electromagnetic radiation wave in incident on a particle on or atom or molecule or change particle, then the light may be refracted or scattered. When radiation is passes through a transparent medium, the species present scattered a fraction of beam in all directions. Scattering of light is the phenomenon in which light ray get diverted from its straight path on striking on obstacle like dust or gas molecule, water vapor, etc. Scattering of light may be divided into two types. That it occurs due to two collision. One is inelastic collision and second one is elastic collision. In elastic collision there is no change in energy, and in inelastic collision change in energy as incident radiation skidding on the molecule surface. Then the molecules emit the radiation. It is of the same frequency as that of incident radiation. This process is known as relay scattering. Now, second one is the inelastic collision. In inelastic collision, here there is a change of energy, exchange of energy. That is, molecule is radiation incident, then some same energy of the radiation absorbed by the molecules, and molecules will emit energy less than the incident energy. So this type of effect is known as Compton effect. Among the all of these, Sir C.V. Raman observed that some molecules show different type of inner effect, that is, when an incident radiation on a molecules, it shows laser emission of energy and higher than the incident radiation on laser than the incident radiation. So this was behavior of molecule absorb energy or loss of energy with radiation is known as Raman spectroscopy or Raman effect or Raman scatter. Now next one is the Raman effect or Raman spectroscopy. What is Raman spectroscopy? Raman spectroscopy is a molecular spectroscopic technique that utilizes the interaction of light with matter to gain insight into a material makeup or characteristics. The information provided by Raman spectroscopy result from a light scattering process. In contrast to other conventional branches, Raman spectroscopy deal with scattering of light rather than absorption, which is based on the phenomenon of inelastic scattering of molecules, later called as Raman scattering or Raman effect. Photons of high intensity are first absorbed by the sample and the re-emitted in elastic scattering means the frequency of the re-emitted photons is shifted up or down in comparison with original monochromatic frequency. When a monochromatic beam of light was allowed to pass through a substance in the solid, liquid or gaseous state, the light is scattered and contains some additional frequencies over and above that of the incident frequency. This phenomenon is known as Raman effect. Raman spectroscopy is one of the vibrational spectroscopic techniques based on inelastic scattering, which an intense beam of monochromatic radiation, usually from a laser source, is allowed to fall on a sample and the intensity of scattered light is observed at right angle to the incident beam. Now next one is the Raman spectrum. In a Raman spectrum there are three type of line, that is Stokes line, anti-Stokes line and relay line. About Stokes line, the line having lower frequency than that of incident frequency are called as Stokes line. About anti-Stokes line, the line having higher frequency than that of incident frequency are called as anti-Stokes line. Now about relay line. The relay line having same frequency as incident frequency are called as relay line. Now next one is the vibrational Raman spectrum. Pure vibrational Raman spectrum of a diatomic molecule result due to the vibrational transition according to the selection rule. Delta V is equals to plus minus 1. Then vibrational Raman spectroscopy is the Raman technique most widely used in chemical analysis, and it is relevant for the characterization of molecules in the solution. According to the selection rule, delta V is equals to plus minus 1. For Stokes line, it is delta V is equals to plus 1, and for anti-Stokes line, it is delta V is equals to minus 1. According to the wave mechanics, vibrational energy of molecule is given by EV is equals to V plus half of H omega oscillation J, or EV is equals to V plus half of omega oscillation centimeter inverse. In the pure vibrational spectrum, a Stokes line will appear as Vs is equals to Vi minus omega oscillation, whereas anti-Stokes line will be at Vs is equals to Vi plus omega oscillation. Now next one is the rotational Raman spectroscopy. Here I absorb the diagram in this rotational Raman spectrum. Delta J is equals to plus minus 2 transition. Only those rotational transition are allowed for which delta J is equals to 0 or delta J is equals to plus minus 2. When delta J is equals to 0, the scattered Raman radiation will be of the same frequency as that of incident line, that is relay line. When delta J is equals to plus 2 gives Stokes line, and delta J is equals to minus 2 gives anti-Stokes line as rotational transition diagram. Now first line is separated from the relay line by 6b, whereas subsequent lines are equispaced and separated by 4b. Raman rotational spectrum showing in diagram. Now Next one is the characteristics of Raman spectroscopy. In the intensity of Stokes line is always greater than anti-Stokes line. Raman shift is generally lies within the far and near infrared region. Raman line are symmetrically displayed above relay line. Raman line are due to change in polarization of the molecules. Now coming to the last one parts, that is application of Raman spectroscopy, analysis of molecule properties. The observation of the position and the intensity of the Raman bands provide key information to study molecular structure, intermolecular interaction to determine the chemical intensity of the sample. The lack of sample preparation also minimize cleanup and the possibilities of cross contamination. Investigation of inorganic system. The Raman spectroscopy is often superior to IR spectroscopy for investigation of inorganic system because aqueous solution can be employed. Further vibration energy of metal ligand bond are in range of 100 to 700 centimeter inverse, which is difficult to study in IR spectroscopy but can easily studied by Raman spectroscopy. Thank you everyone for giving you valuable time for this presentation. Thank you.